Microelectronics is the backbone of modern technology and underpins capabilities in virtually every sector. Cell phones, computers, military systems, automotive systems, medical devices, all of which are vital for national security and economic competitiveness. However, long-term domestic economic trends have moved U.S. microelectronics fabrication and production abroad and deteriorated U.S. manufacturing capabilities. While recent incentive plans, including the CHIPS Act, will shift more microelectronics production onshore, most facilities are focused on near and medium-term technology capabilities. They target primarily large and mid-sized corporations and are not enough by themselves to regain U.S. dominance in the long term. Addressing this gap will require new innovative technologies to leapfrog existing capabilities. Welcome to IQT Explains, a series on the IQT podcast where we explore global technology trends and their impact on national security to provide you, our listeners, insights and unique perspectives. I'm today's host, Fareed Nemri, and today we're going to discuss breakthroughs in microelectronics and how the industry can impact national security and beyond. To get things started, I'll introduce today's guests, Dr. Zheng and Michael Falcon. As Chief of Staff, Jan aligns priorities across IQT's leadership team, coordinates engagements across the U.S. government, and implements business strategies designed to execute IQT's mission and vision. Prior to this role, Jan served as Vice President of Technology, leading investments in microelectronics and quantum technologies to solve critical mission challenges facing our mission partners. Jan, thank you for joining me today.
Hi, Fareed. Thank you for having me.
Of course. Our second guest is Michael Falcon. Michael is a partner on IQT's investment team and co-lead of IQT's Intelligent Connectivity and Compute Technology practice. We call it IC2. Michael has over 20 years of venture capital and operating experience, with an emphasis on deep tech and microelectronics industry sectors. Michael, thank you for joining us virtually.
Thank you. I'm excited to be here.
Again, thank you both for joining us. I'm really excited about today's conversation. And to get things started, we'll go a little bit high level. So from Chris Miller's chip war to the CHIPS and Science Act, semiconductors have dominated national and global discourse recently. Let's begin with an overview of the technology on your end, Jan, and then I'll go to you, Michael, for some market trends. So, Jan, if you can walk our listeners through what microelectronics technology really encompasses and how has it evolved over time?
Yeah, it's a great question. Especially, I think we use a lot of different terms interchangeably. So, we've seen words like microelectronics, but of course, we've also seen words like semiconductors, right? And the semiconductor supply chain. What does it all mean? Really, in my mind, they're different things, but they really simplify the same thing. It's this stuff, the building blocks of the electronics that we use and we really take for granted every day, from the recording studio that we're in here today to the cars that we've driven, right? And a lot of that is really based off of a really unique material set. It's not just one material; it's multiple sets of materials called a semiconductor. This is something that I've been studying for a long time, and it's been one of the core parts of the U.S. R&D ever since World War II. And it's a really amazing device. These materials that make devices that can do things from controlling light, like these LEDs, they are semiconductors, to radio waves, right, and the wireless Bluetooth and Wi-Fi that we're using right now, and everything in between, and the compute. The actual raw compute that we're using right now to power AI engines and such. So everything is kind of based out of down to these devices that are able to do such things. And the trend that really has been driving this, I know Michael will be talking about this a little later in more depth on the business side, is what we call Moore's Law. And that's the other thing that most people have heard of. And aside from semiconductors, when you hear that, you hear Moore's Law. And this is trend where the size of a semiconductor of a transistor will shrink about every 18 months. And by extension, if it shrinks down, it gets more efficient. So the power capabilities actually increase by 2x as well. That trend has really been the guiding post for the industry for the past 50 plus years. And a whole cottage industry has not cottage anymore. It is very well established, but it has grown up around that trend. And to boost it up and to make sure that all the things come out of it. The interesting part right now is that it's coming to an end. Everyone has really looked at that coming to an end. It has created great new and challenging business opportunities for what's next, right? Because we still want to progress, and the finding out that what's next is actually quite exciting for Michael and I and our team in looking in the future.
Absolutely. I mean, In-Q-Tel really sits at the nexus of what's coming next and anticipating those technologies. Michael, I'll go to you on the business side, on economic and market trends. What have we seen? Would love to hear from your perspective.
Well, just to highlight what Yan said, historically, over the last 4 or 5 decades, it has been Moore's law that's been driven the shrinking of the microchips become smaller. However, that trend is slowing down due to the limitations of shrinking the circuits down to the atomic level.
And as things have shifted and changed, as we're coming closer to the end of Moore's law, as we're saying, what are the most recent trends that you've been seeing in the market? What's really manifesting right now and unfolding as we look at ventures, as we look at funding?
Absolutely. So I would say over the past several years, I'd like to highlight 3 more recent trends. I would say the first one is advanced packaging, or we call chiplets. It's really where you do a mix and match of a best in breed circuit designs from different semiconductor manufacturers or providers. And these circuits can actually be manufactured at different process design nodes. And what that enables, basically, it's almost like Lego building blocks of putting these chiplets together into a single package. Another trend that comes to mind is the migration to more photonics or light-based electronics rather than the traditional copper wires. I would say over the last 20 years or so, or 20 years ago, the telecom industry pioneered photonic devices for long-haul communications between cities and countries. Now, more recently, these photonic devices are being designed to connect these chiplets, again, these Lego building blocks I referred to, together over very short distances, or connecting components within a computer together, or between servers within a data center. As an example, In-Q-Tel recently invested in a company startup called IR Labs, which is developing high-speed chip-to-chip optical interconnects, which is targeting connection distances of less than a millimeter up to 30 meters and beyond distances. And then lastly, I would say a third trend is moving beyond the traditional silicon, which has really been the workhorse material system for the past 40 or 50 years. And specifically what I'm referring to is the fabrication of certain power electronics and RF devices using different material systems, such as gallium nitride or silicon carbide. These compound semiconductor materials are better suited for the high frequency operations and can handle significantly more power. And just as an example, IQT has invested in a company called Finwave Semiconductor, which spun off of MIT. It's developing a gallium nitride on silicon fabrication process, as well as a high-speed multi-gigahertz RF switches and RF power amplifiers.
Yeah, that's great. I think one of the really interesting things of the 3 trends that Michael brought up is that in the past we took Moore's law for granted, right? Like that it can't be understated how powerful that kind of reliability, almost like a clock of, hey, it's going to get better in 2 years. So why would anyone invest in any new technology, right? If I could just wait, 18 months and then get a better. So like every startup company at the time had to say, I'm not only 2x better by the time I'm developed this thing, I have to be 4, 5, 8. That is a really hard and like a high barrier to cross. And so I think there was almost a tyranny, what I call a tyranny of Moore's law, right? We just depended on so much that it was very hard to make any other arguments to like invest in other technologies. The cool part now is we get to this stage where there are other technologies that we know are out there, and now there's the business case, which is I think the neat part. The business case that says we should be looking at this now, and there's a lot of cool opportunities that come with better integrating silicon photonics, integrating new materials, and then having that platform that Michael mentioned about chiplets to be able to put all these disparate, diverse parts onto a system. We never really explored that before because we never had to. right? And now gives us it's just a cool opportunity to start looking at this space.
Absolutely. I mean, what an insightful observation from you, Jan, on that end, and a comprehensive overview on the market trends, Michael. Thank you for sharing. And it got me thinking about, okay, so there's a new opportunity. There is an unfolding or new business case for some new technologies that may not have had the same opportunity or visibility as before. Where are we lagging when it comes to the industry? I'll start with you, Jan. When thinking about the technical expertise or the technological R&D, what's moving too slowly?
Yeah, I think some of the areas that are moving too slowly are our ability to actually make these things, like make these chips. Again, we've been so accustomed to building almost the same thing, maybe just a little bit better each time. These silicon products. That in this brave new world now, where we have to not only make silicon but make gallium nitride. Oh, by the way, they also make light emitting products, and then we have to put them together. Those are all new muscles that we have to exercise, and to exercise those, you need new equipment, right? And what is that equipment? Who's making that stuff? Where is that being manufactured? We are kind of behind the eight ball there. Many of that has already gone abroad. Because it's we're just trying to, maximize efficiencies, right? Now we're in a new stage where we have to we can't rely on that anymore. We have to start doing it ourselves. And so there's that, we have to kind of get back to first principles. How do we make these things? What are the tools necessary? What are the basic material building blocks now? And to start to engineer with. We need to start getting into that, and I think later on, Michael and I can share some of the insights we've gained in investing in this space, because it is a space that we've as investors have also kind of left, right, and then we need to get back. It's not just technology; there's a business case of needing to come back to it as well.
Absolutely. And this got me thinking about something I've either read or heard recently about. There is this high focus, especially geographically these days, on certain elements of the value chain. So we see Korea focusing on memory chips. We see a lot of design in the U.S., of course, the Netherlands when we're thinking about lithography. And that's good to have expertise in certain areas, but it gets us to a potential issue, as you're referring to, of we may not be good at some elements and new materials, new equipments. Michael, as you're observing those trends in the variety of elements or categories of the value chain, we're thinking about design, manufacturing, fabrication, advanced packaging, all of that. Have there been some funding gaps? Are we seeing more money going into one area versus the other? And is that disparity of concern to you?
The short answer is yes. The way IQT views the microelectronics value chain is it basically has two primary parts. The output of the value chain, which is the chips themselves, and that could be a microprocessor, it could be a computer memory chip, and it's the inputs into the value chain, which are the ingredients needed to fabricate that actual microchip. And this includes process equipment, design tools, software design tools, electronic materials, and the packaging and testing. And in terms of funding gaps, specifically for startups, I would say that the inputs have traditionally been underfunded relative to the actual chip companies themselves, because developing a fabrication or foundry equipment is very capital intensive. Over the last 10 to 15 years, most VC investors have shied away from funding semiconductor manufacturing technologies. IQT analyzed actually this funding gap, and today less than 10% of the VC funding is flowing into semiconductor manufacturing, or again, the input side, compared to the outputs. At IQT, we've invested in over 70 plus microelectronics startups over the last 15 years. And this includes both the inputs and the output side. However, I would say over the past 2 to 3 years, we are trying to target more of the inputs, or again, the manufacturing supply chain piece, because of this funding gap.
That makes sense. Thank you for sharing, Michael. So for our listeners, they hopefully by now got a good overview of how the market has been looking, what the technology is really about. But what gets a lot of people thinking, and why it's been in the public discourse recently, and why I myself, for example, as a non-expert in the field, am really invested in where these things are going when it comes to semiconductors, microelectronics, is the national security impact.
Mm-hmm.
So what I would love to get us thinking about and discussing is, why does this really matter, and why does this really matter for In-Q-Tel? So it's critical, obviously, for supply chain, critical for resiliency there, critical for a lot of the tools that we use. But for those that are not very familiar with the national security impact or the direct ties there, I'll ask you, Jan, why does it matter, and what are some of these applications in national security and military intelligence, defense overall, that we're thinking about and have a strategic view of when it comes to microelectronics?
Absolutely. Yeah. Let me start just at that very high strategic part, because I think Michael mentioned a really cool and really important aspect of just the global nature of the supply chain. And I think we think so much about what China is doing, right, in the supply chain, but really, if you look at the supply chain, about 80% of the microelectronics supply chain are in democratic and aligned countries, right? So this is South Korea, Taiwan, Japan, the EU, right? And so it's important that why In-Q-Tel has a footprint globally and looking at some of these and working with our allies in these countries and understanding what's happening because of how this is a global supply chain, and we have to leverage the fact that we do have allies in this, right? And then that's important for us to further understand what they're concerned with, what's going on with their neighborhoods. And so I want to stress that fact that this is still is not something we have lost. I think there's still some opportunities for us to really work with our allies here. But on the technical front, I think what's taking a lot of oxygen in the room right now is just AI, right? Of course, everyone wants to use AI from the military to applications to like a ChatGPT application, right? And of course, what's running that? These are like these advanced processors, not only in the NVIDIA GPUs right now that everyone's talking about, but things that we've recognized in our team, over 8 years ago now, in what are the processors? What is the advanced compute necessary for AI? And we invested in a large number of those, Grok, Cerebrus being some of those that we're excited about. But I think if you put that aside, there are a tons of other applications. If we were talking about a future where we have autonomous drones and swarms of those, well, what is the brains of those things, right? Like how do we take the smarts that are in large data centers that are not moving and into a mobile power constrained system, right? What is the cost implications of that? Like that's all microelectronics, and a lot of that's driving the cost and development there. Even more mundanely, we've learned through the pandemic, right? And Ford and a lot of the other car manufacturers learned this the hard way, right? If they ignore and the microelectronics industry and kind of take for granted, right, what's powering their cars, they had a rude awakening where they realized that a $50,000 car is being held up by a $5 chip, right, that is running a sensor, oxygen sensor, or running an infotainment system, right? They weren't paying attention to those pieces. In automotive, those are legacy pieces. I'm not even talking about the most advanced chips. When you look at the DoD, that's even worse. They're running 15, 30-year-old technologies, and for them, it's like that's what the guidance system on an Abrams tank is using, right? And there's probably only 10,000 of those manufactured, and the supply chain of that is something the government will have to maintain, not the commercial sector, right? And so like there are a lot of challenges there all for a small few dollar chip, but is critical to actually making the whole thing work at all.
Absolutely. So there's good news. We have good allies and good alliances out there, but we can't get too comfortable.
That's right.
Excellent. When considering those those issues and those challenges, Michael, on the business side, on market trends and funding, what are the risks associated with relying too heavily on foreign design, manufacturing, foreign capabilities? But I would even take it one further step in building on Jan's discussion. Maybe some not so friendly or adversary or competitive foreign entities rather than just maybe foreign allies. What are some of the risks that come to mind from your perspective?
Well, there are definitely multiple risks in terms of relying on foreign countries for chips. Specifically, maintaining a secure supply of chips is critical, and Jan already touched on this. I mean, during the COVID pandemic, the U.S. auto industry was disrupted because the auto OEMs were having difficulty building vehicles because of the chip shortages. In terms of what, I would say the economic or the market disruptions of greatest concern, I would say it's on the fabrication side of the
Mm.
chips. Again, that's the foundries and that are building the chips, as well as the other ingredients, the materials and the equipment that are used to build the chips. Um, it's well known that the majority of advanced chips are currently being manufactured and packaged in Taiwan and other locations. And of course, the $52 billion U.S. CHIPS Act is helping to onshore more of the microelectronics manufacturing.
Hmm.
But again, a good portion of that money is being allocated to the larger semiconductor companies. IQT, our focus is on fostering new microelectronic startups that may be able to leapfrog some of these existing near term capabilities in terms of manufacturing the semiconductor chips and designing the outputs of those of the value chain, the chips themselves.
Absolutely. This is what I wanted us to take the conversation, actually. So I'm glad you touched on that, Michael. I mean, being IQT and working at the nexus of emerging tech and startups and looking at what's ahead of us, we very diligently and concretely understand and know and get to observe how startups have played and continue to play a pivotal role in pushing the innovation boundaries. And I always like to think that every big tech or large institution out there started as a venture, as a startup. So looking at where we are right now and the role that InQtel plays, let me discuss with you, and I'll start with you, Jan, especially on the technical side. You've been working on this, and now as Chief of Staff at InQtel, you have a strategic view of how we look at investments, our approach, where we see things heading.
Mm-hmm.
What are the guiding principles for InQtel when it comes to microelectronics?
Yeah, it's a really good question. Like Michael said, we've been investing in this for over a decade. 70 plus different investments, and the goal of that has changed over the years, right? We started out with a lot of the catching the before the wave of wireless, right? A lot of our early microelectronics ones was like wireless RF, Bluetooth. Now everything is wireless here. And then again, we mentioned we were looking at the AI powering AI, like what it was doing that before the rise of these LLMs, and we were lucky to get into a lot of those deals. But to Michael's point about what's the gap we're seeing now, which is the manufacturing production of these chips, that for us, there's three main guiding principles, right? We call it disrupt, protect, and insight.
Oh, I like that. Let's repeat that for our listeners.
Right. So disrupt, protect, insights, and those are the three things that when we look at this space in particular, that those are the guiding principles. So let me describe kind of what that means to me. When we talk about disrupt, we're looking at investing in technologies, right, that can fundamentally change the way we make produce microelectronics, right? Especially to break free from dependencies, right, and or to make investments by other countries, in albatross, because we've moved past that technology now. We've now disrupted the field, right? So I think looking for those key manufacturing tools, components is going to be critical for disruption. But but we also have to recognize that this is a brown field, right? This is we've been working this for a while. There's a lot of incumbents in this space, and so it's important for us to also protect, right? In this space, right, provide guidance to help nurture and the health and development of critical semiconductor startup companies, right? That we think will have a potential critical need for our partners, our allies, right, and the kind of the health of the ecosystem, in general. And we do that because as with our every investment that we make, we are board observers, right? And so take advantage of that to be able to have those candid conversations and understand what's going on. And then the third one is to develop insights, right? Because this is such a complex global supply chain, right? You can't just muddle way through this, right? Because there's a butterfly effect. You make one decision and it goes down the line, right? Absolutely. Just like the automotive folks, they didn't know that tier 5, it's the OEMs were buying chips in certain places, and now that holds everything up. And so I think the same thing here for our partners, for our government and elsewhere, to better understand how the space and how to do that, and that's why we think the third pillar of this is how to develop insights that really help to identify the criticalities and then the opportunities within the semiconductor supply chain. And those are the three things that Michael and I and the rest of the team have used in making our kind of key critical investments. And we made a number of investments along those, ones that we could slot into each of these, or if not more than one of these guiding principles. And very excited about where they're heading.
Absolutely. And those insights, that third pillar or guiding principle, the more insights we generate, the more effective we are at going back to the first two of disrupting and protecting.
Absolutely.
So that absolutely makes sense. Michael, I know as an insider myself that, and as we've mentioned throughout the discussion now, In-Q-Tel is one of the most prolific investors when it comes to microelectronics, and we've been doing it for a while now, not just with the new buzz or the new attention that has been unfolding, especially with the onset of the pandemic. Can you share a little bit more? We've mentioned a few portcos we've invested in, but just taking our listeners through some of the investments, the breadth, the depth of the investments that we've made, and maybe reflecting that into the supply chain or the value chain of how that provides a comprehensive strategy for In-Q-Tel. Would love to hear from you on some examples there.
Yes, I know this was touched on earlier. In-Q-Tel has invested in over 70 microelectronics startups over the past 15 years. So I'll touch on two. To begin with, on the output side, which is the chips themselves, IQT has invested in a chip company called Cerebras. It's developing a large wafer scale chip. It's basically a chip company for AI deep learning applications. Cerebras's chips are nearly the size of a dinner plate. And they contain over like 900,000 process cores and 44 gigabytes of on-chip memory. And then switching over to the input side or the manufacturing supply chain, IQT is invested in a startup called ChemPower, which is developing a new type of CMP, which stands for chemical mechanical planarization. It's a technology. ChemPower is actually a slurry-free technology to do CMP. Traditionally, chemical mechanical planarization is a fairly dirty process when it comes to semiconductor manufacturing, which is done in a clean room. It's analogous to basically using sandpaper. You could think of ChemPower's technology as a magic eraser that planarizes the wafer after each lithography step without a slurry. ChemPower's technology also reduces downward forces on the wafer surface, so the yields could be significantly boosted. So again, just in summary, Cerebras is one example on the output side. ChemPower is an example of semiconductor manufacturing input side of some investments we've made.
And in fact, I think to the guiding principles, ChemPower is a great example of both the protect and disrupt kind of principle. I mean, so one of the things that that's important that why Michael mentioned this for ChemPower is we talked about like extreme UV lithography. That's like the thing everyone's looking at. Like only one company in the world, a Dutch company, is able to make this machine that produces light at such a small wavelength, right? That allows us to make these really tiny transistors, and that's a $350 million plus machine. And only one place in the world that makes it. But one of the things that the insights that Michael and I had was, well, if you before that step where you shine that light on it, before and after that step, you need to do a process called CMP. You need to make sure that your wafer is smooth as possible before you put this really expensive light, on it. And if you don't do that well, then all that money you spend on the EUV is wasted because you have to do it over and over again, right? And so, like in the whole CMP process, that machine is probably $3.5 million. So it's like 100x less expensive, and yet it's critical because you do that next to this really expensive process. So in terms of disrupting the market, like everyone's focusing on how do we make the U.S. version of EUV, and yes, we should be looking into this, and we are looking into this. But at the same time, it's like, well, guys, there's probably a simpler solution here too. What if we disrupt the market by controlling this one step critical to EUV, right? And that's kind of the reason why we did that. And look, it is a U.S. company. It's a U.S. company, and one of the leaders of making CMP machines is a U.S. company, tools manufacturer as well. So let's make sure we give those companies the best boost they have and protect their slice of the pie, right? Make sure the U.S. is still making critical tools.
Absolutely. What an excellent example that showcases how intricate the value chain and the supply chain, and how each process, no matter like how small, how simple or complex, it has a prerequisite, either material or process, right, before or after it. And we, as you mentioned before, we cannot ignore anything. We need to protect what needs to be protected and disrupt where there's opportunity.
Absolutely.
To wrap things up, speaking of disruption, speaking of what lies ahead, taking a step back and thinking, okay, we've done some things pretty well. We have strong capabilities and we have good allies working on strong capabilities as well. But how should we reimagine our specifically national approach, working closely with the U.S. government? How should we reimagine our approach when it comes to microelectronics and innovating within that industry so that we are not in 20 years, 40 years, looking back and saying, we missed the mark?
Yeah, absolutely. That's the critical question. And, to be blunt, I think really we need to scrap the current model for innovation. Right? The model right now, it's 75 years old, right? This is, it's a model we call the Vannevar Bush model for linear. Vannevar Bush was one of the leading scientists in World War II, right? He was the first director of NSF, and he led his paper called Science: The Endless Frontier is what every person doing science policy has cited for the last 75 years as, the U.S. model for innovation. You start with, the universities, basic science research, funding that, and then it'll go to an AT&T Bell Labs, right? And then it'll pop out as some product down the line. We know that's not the world that we live in today, right? AT&T Bell doesn't even exist in the same form as it did, to today, right? It's not this centralized, linear, motion of technical innovation anymore. We live in this space now where we have 5 times more money going into R&D from the private sector than we do from the public sector. Back then, it was not the case. So you have many different actors with their own incentives, right, doing parallel efforts. And really, I think the goal right now is how do we align all those efforts, align the capital, align the incentives and the mission towards key national priorities like microelectronics, maybe like bio and energy security, right? Do that so that we are able to all kind of work together as a community, right? We just have to understand that the way we did science back in the day is not the way we do science and engineering today. It's done differently, but how do we capture that, right? How do we capture the energies and the money going into that so that we go and we all row in the same direction?
Absolutely. Well, what a note to conclude our podcast at. I want to thank you both for taking the time to speak with me and to educate me and make me smarter on this topic. And hopefully our listeners feel the same and, find your insights illuminating on what In-Q-Tel has been up to, but more broadly, how we think about things and how the market has shifted and the technology has advanced and evolved. So thanks again, and thank you to our listeners. We appreciate tuning in to today's episode of IQT Explains on the IQT podcast. Please make sure to subscribe to the IQT podcast so you don't miss any future content, and leave us a review or a comment. So if I missed a good question you have in mind, please leave that as a comment. We'll try to capture that and address it in future podcasts and specifically on this topic. I also encourage our listeners to check out our website, iqt.org, and that is www.iqt.org. Please explore more content there and learn about IQT's global investment platform that accelerates the introduction of groundbreaking technologies to enhance national security and prosperity of America and its allies. Thank you.